Hi everyone, my name's Jordan Marshall and I'm Chief Reporter at Building Magazine. I'm so excited that I'm getting the opportunity to chair the first session in this year's Digital Building Week. And it's all about how we can boost the use of MMC and offsite through collaboration. So we've got a really great panel today. I'd love to welcome Isla Jackson, Jamie Johnston, James Garner and Michael Ruddick, who will each be giving a presentation to kick things off for us before coming together for a Q&A. We'd love our audience to get involved, so please send through your questions at any point, and we'll try and get as many of them to the panel as possible. Also worth flagging now that it is the case that this session, as with all the Digital Building Week sessions, will be available on demand about 30 minutes after they conclude, and they are free to attend and free to watch on demand. So if there's anything you miss and you want to review, please feel free to come back and watch it again, or if you want to share it with somebody else, that's also fine. I think that's probably about it from me for now. So I'd like to kick things off by handing over to Michael, who'll be our first presenter today.
Good morning, everybody. I hope you can all hear me. I was just Jordan's kindly introduced, Michael Ruddick. I'm the Commercial Director at Reds 10. I'm just going to go into my presentation here on, how we can boost the use of MMC offsite through collaboration. So my first slide here, basically from a contractor's perspective, and the first thing I want to touch on is we're a vertically integrated MMC contractor, which we believe gives a deeper level of collaboration. So when I talk about vertical integration, what I mean is we control the process, we own our own factory. So from the outset of a project all the way through the build to completion, we're in control of that, and we feel that it draws more people in sort of earlier into a scheme. There are a number of benefits to this, as you can see there on the table. So it gives greater flexibility, greater improved predictability, earlier revenue generation. We think it includes the quality of the build because we're in factory conditions, better asset performance during operation, and better customer experience as well. We also believe it's more affordable. I think it works out cheaper from both the contractor and the client's perspective. You get sort of lower prelims because reduced time on site, improved productivity, eliminates a lot of duplication, eliminates rework, reduces peak cash flow and improved whole life costs. Also, it's quicker. On-site time is reduced significantly. Overall development time can be reduced, and a PMV, pre-manufactured value, is enhanced as well. And ultimately, MMC is helping to lower carbon. Firstly, it's reducing the carbon in operation. We're using more environmentally friendly materials. In terms of the actual manufacturing process, it reduces carbon, and we've got reduced wastage in the factory, the reduced vehicle movements, and also it's got the added benefit of end-of-use recycling when the building comes to the end of its life. We feel, overall it's helping, with the whole carbon agenda. MMC is reducing embodied and operational carbon. Okay, so more specifically about MMC collaboration. I think when everyone talks about MMC collaboration, it's often mentioned, the buzzword is I'll get the design team involved earlier. However, there's a lot more aspects to it, which I'll go through now, which feed into that collaboration. So first of all, you've got the factory element, the guys actually on the factory floor. So we're getting input from the guys who are actually building it. Because we're vertically integrated, we've got that line of communication. We all work together within a factory environment. So they're feeding back into us and the design team on what works, what doesn't work, and we're getting real-time feedback. Also, we've got the site installation team. So what works in terms of, when it goes to site, how we leave the roof, the bay joints, that's all fed back into the process as well and fed back to the team. And also a really important part is the pop-up and bay connection, so below ground drainage and so on. I'll come on to it later. I'll show an example of a builder's work hole and how it's used, and how through having a federated model, we can coordinate where the pop-ups are and make sure they're in the right place. The site fit out, so we can improve the speed of the site fit out. We're reducing the amount we'll have to do on site, and we're increasing what we can do in a factory. And as I touched on earlier, this is helping with reduced site programs. Cost, so the design reflects the budget. Also, one thing we have found on cost is we know our costs because we're building the same thing again, and we're getting to a stage where through collaboration and standard details and federated models, we know exactly what it costs us to build because we're doing the same thing again and again. So we're getting that cost advantage, and also we've got the opportunity to reuse any stock materials we have. Supply chain partners. A big part of what we do is we involve specialist subcontractors in very early in the process and get them to work with the designers. So that might be the external windows and doors. There's always a lot of detailing around that, internal doors, the structural steel frames, the M&E subcontractor. These guys and the supply chain partners we've got are all working in Revit, and they're feeding into our standard details and liaising with all the designers. So we've got the collaboration there as well. Also, the compliance with building regs and any specific client requirements. When I talk about client requirements, specifically if there's net zero, you're designing for net zero from the outset. If there's BREEAM or a DREAM requirement, again, that's the whole team's working on that from the outset, and smart building technology. And then also we've got the federated BIM model with standardized details. So if we just go. So development of a fully federated model. All of the items on the previous slide sort of feed to and inform the federated model. This is helping us to improve design coordination. Elements such as pipe, clash detection there. You can see on the diagram we've got some examples of pipe and containment, AC and FF&E and data and that type of thing. So it's helping with those. And it's increasing our PMV, and ultimately it's reducing site works. So yeah, so those diagrams there just showing some examples of M&E and FF&E clash detection. Next, come on to standardization of design and the power of having a fully federated model. This slide here shows some of the standard details we build to in our factory. We keep these stored centrally and continuously review and update these. Also, we've got constant feedback coming back from the guys on the factory floor. Our operatives are actually doing the works. So if they say a detail doesn't work for any reason, that's fed back into designers who then update the standardized detail. So there's that constant sort of 360 review going on. And also, I mentioned earlier, you can see the bottom three diagrams there. It shows you've got the standardized detail there for a builder's work hole, and then you've got the 2D plan there, which it references the detail for the builder's work penetration, and then finally you can see it in action there, where that green box is the builder's work hole for the pop-up for the drainage there, and that's all modelled and overlaid. One thing we do is we do an as-built survey scan of the drainage and the foundations. We then overlay the federated model on that before it comes to site, so we know where we've made our builders work holes are accurate and the drainage is in the right position. So that's it's a great advantage of using the federated model and the whole collaboration around it. Ultimately, the MMC and the whole collaboration is it's helping show how we can reduce both the embodied and operational carbon. And I think MMC has given us a head start on this. What we've got here is an example of it was actually an MOD accommodation block we did. We did a prototype to begin with, which is the Westdown Nest Cap. You can see on the top table there, we've got the EPC rating. The first one we did had a rating of 12, and then sort of through design development and working with all the team, we've improved on that. and that was looking at all aspects of the build, how we could reduce the operation carbon, but also the embodied carbon too. And you can see a few buildings later, we're now net zero, we're at -9, so we're performing really well. Also, in terms of, sorry, the bottom table there is the embodied carbon. So we looked at calculating how much embodied carbon we reused on the first one, and now to what we used on the second building, which was reduced significantly. And that was things such as removing the concrete floors and going for a concrete GIFA particle board. So we lost the embodied carbon from the concrete there, and going from having china troughs and in urinals to having metal instead. So I think we think the vertically integrated model and MMC collaboration is better than traditional. I think traditional is, can be very segregated and doesn't give the opportunity for the collaboration that MMC does. So I think that's my presentation finished now. So I'll
Brilliant.
Jordan, if you'd like to take back control.
Yeah, brilliant. Thank you so much, Michael. That was a great way to kick things off. Next, I'm going to hand over to Isla Jackson, who is going to be our next speaker this morning. So I'm just going to make you the presenter now, Isla, so that should all be popping up for you. And I just quickly, while I'm still on here, I'd like to reiterate that yes, everything will be available after the session on demand. We've had a few people asking already. And if anybody has any questions, please just send them through as they come to you. We'd love to cover as many of them off as we possible. So great, Isla, I'll hand over to you now.
Morning, can you hear me and see my screen?
Yep, all perfect.
Brilliant, thank you. So morning everybody, my name is Isla Jackson. I'm Director for Civic Engineers in our Scotland studios, and we've been working on quite a few projects recently to do with modular construction and offsite construction. So the benefits of modular construction, I'm sure you're all well aware of it, particularly in logistics in remote areas. We've got a project up in Shetland, for example, which I'll touch on further on in the presentation. Availability for space and space for laydown areas also very helpful. Availability of skilled labour, again, particularly where you're performing the construction in remote areas. Reduction of construction time, which has already been touched on, and better quality of construction because it's factory controlled, and fully integrated services and glazing, etc. So the project that we're working on in London that you can see just on the right hand side of that slide is 215 homes just in London Borough of Greenwich. And basically we've been working with the contractor to develop the modular construction for each of these modules. I think there's still a way to go yet in terms of optimization, but it's been a real learning curve for us as civil and structural engineers to really try and work with the factory and make sure that we're making it as efficient as possible, both in terms of being able to fabricate it easily, but also from a constructability point of view. But there are challenges, and I think this is probably the angle that I was coming at it from. How do we actually approach these challenges for modular construction? And I think what we've learned certainly recently is that early knowledge sharing, both between the client and the contractor or the manufacturer, and early coordination, particularly for things like balconies and details like that. It's the overall responsibility, particularly in Scotland, and I'll touch on the difference between Scotland and the rest of the UK in terms of who's responsible for the overall design, structural stability of the building. But there are other things that we need to have a look at, and fire stopping in particular is something that should be considered. There have been a couple of incidents. Oops, can you still see? You see that okay still? There's been a couple of incidents in the Shetland Isles in particular where there's been fires, one in the Moorfield Hotel and also the Fair Isle Bird Observatory, which both of those buildings were lost. Luckily no loss of life. But that is something that makes people a little bit nervous in terms of modular constructions. Perhaps we can have a discussion about that later on. at the panel discussion. So just slight differences between Scotland and the rest of the UK. We have SER, so Structural Engineering Register in Scotland, and that means that a certified engineer has to take responsibility for the overall structural performance of the building. And that means that we have to check, even if it's a subcontract item such as balconies, for example, we are responsible for checking that those calculations have been carried out to our satisfaction, to make sure that the building has an overall owner, if you like. And again, following the Grenfell tragedy, there is more of a highlight going forward. I think it's the new fire safety bill, which is looking to have an accountable person on projects. And so that may become more and more a thing that becomes more highlighted, I guess, across the full UK. But it is quite interesting when you're doing projects both in Scotland and England, how different it can be in terms of the approach and how you use stage warrants, etc. for building control. So this is just an image that was taken from the iStruct-T. They're busy at the moment coming up with all sorts of different elements. Again, I think Michael touched on the advantages of modular MMC in terms of the carbon. But again, I think we need to have a look at it and really challenge ourselves as designers in particular. As you can see at the beginning, 50% of the embodied carbon would be within that first section of either product manufacture or design. So we really have to kind of challenge ourselves as to where the materials are coming from, how they're being transported to site, and the manufacturing methods that are actually included to really get the overall view in terms of how well it performs in terms of embodied carbon. In terms of the next phase, which is construction, clearly there's a real benefit to MMC in terms of the reduced construction period. But you can see there that it's actually quite a small element according to this diagram in terms of the overall contribution to embodied carbon calculation. And then interestingly, 20 to 22% is the in use, and then end of life is 2%. And that's the cradle to grave approach, which we're all probably quite familiar with. However, there's also the circular economy element, which again is more and more coming to the forefront. And actually, it doesn't go cradle to grave, it's more cradle to cradle. And we should be looking at how we actually deal with those buildings, how we take them apart, how we reuse and put that back into the system. So this cradle to cradle circular economy approach is probably something that we'll see more and more, particularly as we're starting to challenge the industry as a whole is starting to challenge itself in terms of how we design things, selection of materials, how we go about minimising our carbon footprint. And then this is just really a slide to show that in terms of reuse of buildings, if that's an option, that is preference, I suppose, in terms of knocking them down. And it's the combination of modular and building reuse that is really interesting. And more we're seeing that in terms of existing buildings being renovated and modular construction because of its weight savings, etc., being used to, particularly residential, to place penthouses and apartments on the top of these existing buildings. So I think that there's a real opportunity as an industry for us to have a look at how we calculate the carbon correctly, and we're not kidding ourselves that that it's just a one-size-fits-all approach. Obviously, we have to have a look at the whole thing, and that could be from the reuse of foundations from an existing building if it has to come down, or if there's been a fire, for example. We're working on the Fair Isle Bird Observatory, which did actually burn down and was modular construction. But they're going again with modular construction, but reusing the foundations. They have a very short window, as you can probably imagine, just being south of Shetland in terms of being able to construct. So it's an uninhabited island, very difficult in terms of logistics. There are no skilled labour actually on the island, so they only have a 6-month period to be able to construct. So the only option that they really have to do it within that 6 months is to go modular. So I think there's lots of things to consider. There's a way to go yet, but I think probably my sum up would be it's that early involvement, real challenge at the beginning with the client's buy-in to the material selection and how we actually go about designing it, and making sure that we have somebody who's overall in control of building for all elements so that it can be looked at holistically. And that's me for just now.
Brilliant. Thank you so much, Isla. I think that's a really insightful and different perspective on the topic, and I think some really valuable points in there. Next, I'm going to ask Jamie Johnston to join us, and I'm just making you presenter now, Jamie. I'm also just going to flag our next two presentations both include a video, which there will just be a second's pause before those videos play. Bear with us; they will start as just a second's lag. Also, just worth flagging. Occasionally it's that the sound doesn't come through immediately for a rare few people in the audience. It will just be your sound input, and GoTo will pop up with something just asking you to switch your input. So it will work, and it will all be on the on-demand sessions as well, but just yeah, give us a second with those. Okay, thanks very much, Jamie. I'll hand over to you.
Perfect. Just checking you can see my slides all right?
Yeah, perfect.
Good stuff. Okay, hi all. Thanks for listening. My name is Jamie Johnston. I've got a couple of roles. So you can see here I'm a director at Bryden Wood. I'm also the platform design lead for the Construction Innovation Hub, which I'm going to touch on very briefly. So yeah, so collaboration's definitely, from the talks you've just heard, it's an essential part of developing MMC solutions. We can't develop MMC solutions without it. As an industry, though, we've kind of created some challenges for very good reasons in the way the industry has evolved over the last several decades. But one thing we're very mindful of, for instance, is that this is not atypical of the kind of the range of people you now need within a project team. So whereas manufacturing is much more holistic, much more integrated, for various reasons, the industry sort of atomized itself into thousands of little specialist areas of expertise. We would describe them as sort of deep but narrow areas of expertise, and the gaps between all of those are potential areas of risk. The number of touch points is quite a problem. So one thing MMC needs to do is sort of join up all these roles together, so you have a sort of complete integrated way of working. So that's a bit of a challenge. We also, for again very good reasons, split projects into, we assume a kind of very linear way of working, a sort of sequential way of working, and very often people only work on one part of the project. So you get people who do the first couple of stages or the concept or whatever. As Michael said right at the start, MMC is not really like that. We can be considering something in the manufacturing stage, and it might tell us something about how we should design the overall building. If you suddenly worked out you could get much greater flexibility of spans or grids or something, it might tell you something about the concept design. So MMC likes to be able to sort of bounce around between all these stages, and it doesn't really recognize the kind of artificial stages that we've put in. People also tend to work by sector. So on the right hand side, that's sort of showing if you're an architecture practice, you might only be looking at one sector, one part of that sector in one discipline. And again, that's a huge problem because MMC requires us to be completely sector agnostic. It doesn't recognize these boundaries between discipline and things. So the fact that we're only ever looking at, or lots of people are only ever looking at one part of one sector of one stage of the entire thing, that's a massive barrier, and it's the sort of thing that we need to overcome. Luckily, government has recognised this, and it amazes me actually that more people aren't joining up the dots. So government's been on a mission over the last sort of 4 or 5 years to genuinely transform construction, and they've been incredibly persistent, and they've been incredibly consistent in the messaging around this. So the starting pistol, if you like, was the autumn statement back in 2017. I think lots of people quote the line where it says a presumption favour offsite. That was in there, but it was a summary of a much longer statement. What they actually said was they're going to use their purchasing power to increase timeliness, cost effectiveness, productivity, and I would add carbon, through the use of modern method construction such as offsite. So government said, look, the outcomes need to improve, the process needs to change, and for sure offsite's part of it, but that's not the problem statement. The problem statement is productivity, timeliness, cost effectiveness, and all these things. And over a period of years after that, governments kept getting more and more detailed in its vision. So if the autumn statement said that we're heading in that direction, they're now starting to say, and the end, the end destination is this point. So back in 2018, IPA, the Infrastructure Projects Authority, then put a much more detailed statement and said, actually, we're going to start to look for common components, make those at scale, and that's how we kind of shift into manufacturing space. the same week as that, they set up the hub and said the hub is there to enact that. And then over the last couple of years, last sort of year or so, they've then said actually quite specifically it's these sorts of components, it's these sorts of approaches. So governments now, it said in September, we're going to mandate a platform approach. The last time obviously they did a big mandate was BIM, and it shifted the entire industry. So they've said they're going to do the same thing again, but looking at componentization, and that I think is a huge opportunity for the industry, but it is going to dramatically change a lot of roles and things. So the obvious sort of first question, what are construction platforms? I'm really hoping that this is going to work. You should be able to see a video about now.
Hi, I'm Alistair Hellier, Head of Benchmarking for the Infrastructure and Projects Authority. I'm going to explain in this animation how we need to change the nature of our interventions in the built environment to address the need for social infrastructure using platform approaches to construction. We normally deliver public buildings as standalone projects, and we could deliver more efficiently if we took a different approach. If we could get a shared view of what projects are in the pipeline across the public sector, and if we could see which elements they have in common, we could use that knowledge to invest in construction platform solutions that everyone can benefit from. Having a predictable pipeline and clear rules for platforms would give industry the confidence to invest in product ranges. Products that could be configured digitally, bespoke to the project context, but consistent with the rule set. It would also mean that the associated investment in manufacturing assembly, creating inclusive employment, could be spread across the country, with the assurance that all components will work together as expected when they are assembled on site. Implementation data could then be used to feed back into the system, so that the learning leads to improvement, not just in a single building, but to the design and delivery of all future projects created using the same construction platform or products. This lesson will help us understand whether our investments are actually achieving the priority outcomes we were anticipating, and lead to a virtuous cycle in how we use the built environment to meet the needs of each citizen.
Hopefully you can see my slides again. Can you see my slides?
Yep, all perfect.
Oh, that worked. Well, I was a bit nervous about that. Yes, I mean, that's an incredible, the vision I think is incredible, and this idea of sort of getting down to a level of granularity that you then start to really enable people to manufacture things at scale. That I think is a huge step forward. And one of the things that the government did to put that in place, hopefully everyone's seen the construction playbook. That itself was a collaboration between government and industry over last year. I think it could only probably have happened in lockdown, but I thought it's phenomenal that government sort of used that opportunity to say, right, let's get everyone round a virtual table and let's start to really shape some of these policies. So one of the key ones here was to stop thinking about projects or even programs or even sectors, but say, how can we get above that and start to really identify commonality at a much greater level that will allow us to do all these things and therefore drive these sorts of approaches. To fuel that policy, around the same time as the playbook, the hub published its defining the need report. So again, anyone who's not read this, I think it's a fascinating piece of work where we took £50 billion worth of future pipeline of big departments, wrangled that into a common data set and started to say, rather than look for why each sector's special, let's look for why they're the same. So we found, for instance, out of 50 billion we looked at, about 70% could be built with a single set of structural components. So if you started creating those components, you'd be making them at such a vast scale that suddenly everyone can start to contribute. So you no longer have sort of individual factories making systems, you have factories making cross-sector common components. We also found, for instance, there's 104 different names for toilets across the government estate. So there's loads of potential for standardization and repeatability that's hidden by the nomenclature, and again, having a sort of common language is starting to unlock that. And we found things like hospitals and classrooms or hospitals and teaching facilities, less than half of them are actually clinical or teaching space. Most of those assets are circulation and waiting and plant and all these other things. So again, it starts to tell you something about how we might treat specialist and non-specialist spaces differently. One of the key things that was mentioned in that video, configurators, I won't dwell on this, but the effort of understanding the rules and those commonalities creates a rule set that you could use then to automate design, not to do less design actually, but to spend more time generating more ideas and doing a greater range of test a greater range of solutions. So we're going to see, I think, a very, very different way of designing in the future, where everything is not designed from scratch. Things are configured from standardized components, and we'll use that speed to do more simulation and more testing and better optimization, and we'll get better designs as a result, but it will transform the value proposition for designers, I think. Bryden would have been developing loads of these. Hopefully everyone's seen some of these configurators. At least a couple of them are free and open source. So one of our contributions is to sort of allow everyone to see how we're developing these configurators and hopefully pick them up and run with them. Last couple of slides. The other thing this will unlock is automation at a level that we haven't probably seen in construction previously. So this is a building we're doing for Landsec. It's the first commercial office using a platform approach. You can see here, architecturally not constrained by the fact that it's generated from a suite of components, but we've done things like the fact that all of those components know how they talk to each other means we've automated the modeling process. So we don't make the BIM model or model the BIM model. It's generated from a data set from some key parameters, and actually the BIM model is a view of that data set. So we didn't model it from scratch, and every time we changed something we were to tweak the model, we just generated a new one. So we've seen massive increase in the kind of speed of ability to create this sort of information. We literally, the same components we use in our models, we didn't even draw them. We sent them directly to a company called Easy Space, a tiny little SME, but they've geared up and invest in robots. So they're the first company that are qualified to cobotically weld structural components. But you can see here, all of that kind of handover of information has disappeared. We literally model it once, we send it to Easy Space, they cobotically weld it, and we've then got millimeter or sub-millimeter accurate components coming straight to site, solving all of the kind of normal problems of tolerance and fit and things. This was then how we're building the building. This was our prototyping center, but we're building it for real like this. But you can see here a handful of people. We're able to use non-construction people because you can see here all of the tasks are very straightforward. Again, super accurate components. We're measuring things in minutes. The purpose of this was to see whether we could build the entirety of a superstructure from the floor below, so no one has to work at height. So you raise all the components, they clip into place. Again, super accurate. We're using low carbon concrete, less concrete, robots weld it. So we're getting dramatic increases in productivity, much better accuracy. You'll see here when the shuttering comes down, all of the mechanical electrical fixing points are already cast in. So the MEP is also then a kit of parts that clips in, the facade's a kit of parts that clips in. So we're seeing dramatic improvements in every part of the building process. And one of the key things for us is, rather than try and do everything off-site, we were saying if we can create factory-like conditions on-site, then we don't have the cost and the amortization of the factory, we don't have the transport costs, so we start to tackle all of the kind of wider bits of the ecosystem. So this is my last slide, but you can see here, this is the UK's first net zero commercial development as tested by the UK Green Building Council. That's not coincidence that we're using platforms and getting that sort of result. 24% reduction in embodied carbon, it's net zero in operation, and we've seen a 30.5% productivity gain on the first building that we've done in quite this way. So you can imagine that number's going to increase. But if you imagine those sorts of benefits multiplied by the scale of that 50 billion, you can see why government's heads in this space. And you can see that within a couple of years of the mandate, we're going to start seeing some dramatic improvements in productivity and cost and carbon things. But it is going to require quite a different mindset, I think, in our design, procure, deliver community. So that's, I think, a big topic that we need to start really engaging with as an industry. So thanks for listening and looking forward to answering questions.
Thanks so much, Jamie. That was so wonderful. So much insight there that I'm sure everyone will have plenty of questions, which, as I've said, we've already had plenty flowing in, but please do feel free to send those through. I'd like now to hand over to James, who's our final speaker today. You should have presenter access there now, James.
Brilliant. Hopefully you can see my screen okay, can you?
Yeah, perfect.
Brilliant, okay. So first of all, thank you for having us on the show, and thank you to the other panelists. I found those presentations absolutely fascinating, especially that last one from Jamie with some of those images you showed. Brilliant stuff. I'm James Garner. I'm the head of Insight and Analytics at Leeds. We're predominantly project managers, cost managers, and building surveyors. I also do some work with the RICS. I'm on the construction advisory panel, EPI panel, QS by background. I'm just going to quickly go through a few of the topics and then show a video at the end, which is quite an interesting video recently. So what are the benefits of offsite and MMC? How can early collaboration help improve efficiency, and what tools are available for us? So in terms of benefits, a lot of the other panelists have already touched on these, but one of the main questions that I'm asked as a QS by background is MMC cheaper than traditional? And I know a few of the other presentations have touched on that, but I would say it depends. And it depends in terms of just pure cost on many factors, such as like site logistics, types of materials being used, etc. But I think what's unquestionable is the program benefit from using MMC. And obviously with a program benefit, there comes a cost benefit. So, and the other issue is that you also get a reduction in risk. That kind of controlled atmosphere that you can actually build means that if you're looking at the difference between a sort of contract sum and an outturn cost, I think you'll find with MMC projects, they're a lot less risky. Therefore, you often need to put a lot less contingency on top of the projects because you're dealing a lot with a lot of the issues up front. So that perceived saving in program is really important, because by making sure that you lock that in, you are in effect also getting a cost saving to go with that. But the big but is that the design must be sufficiently advanced, and you must ask yourself what are you trying to get out of MMC in terms of, if it's just cost saving, undoubtedly there are some associated with program, but that is not the only benefit. I think there's so many other benefits that we'll touch on later in terms of quality, program, net zero carbon, all those other things that go with it. And then the cost benefit often is a side consequence of all those things. But what's central to it is the early engagement throughout the whole supply chain. So before work can start in the factory, we need to make sure we've actually got the brief right, we've got the design right, because one thing about MMC is that if you make changes after you've started, they can be quite costly. So that means when you're dealing with your clients, and you need to make sure all stakeholders are involved at an early stage, that design is properly managed, and you go through those early construction stages before those early design stages before the construction stage starts. Otherwise, you're going to evaporate some of the savings that you inevitably get. And then in terms of innovation, I think MMC allows a lot greater flexibility in terms of innovation. I mean, it's innovation in itself, but then the knock-on ability to add innovation to that in terms of the scope to innovate, prototypes, proof of concepts, the fact that you're reducing so much wastage on site. On site is notoriously wasteful. And when I say factory, I also take Jamie's point on board, which is that, you know, the actual site itself can become factory conditions as well. And I think, you know, looking at a lot of the publications that have been issued recently, the construction playbook's already been mentioned, but also issued last week, I think, was the National AI Plan, means that MMC can roll into that. You know, MMC does answer a lot of questions within the construction playbook, undoubtedly, but it also answers a lot of questions in the National AI Plan. So as if we really want to use artificial intelligence, MMC is the way of bedding in a lot of those technologies to enable the AI to do the work for us, both in construction and in use. And then health and safety, I think, is often overlooked in terms of MMC. By bringing the construction process within factory conditions, you are undoubtedly making the whole process safer, which is incredibly important. And then improved and more predictable outcome. So that can be in terms of less risk, improved quality, and all those knock-on effects there. So, you know, a multitude of benefits from using MMC. moving on then to collaboration, I think we did some research sort of towards the beginning of the pandemic that showed that contractors are really starting to look at MMC in a more serious way now. 65% actually of contractors, as a result of our survey, showed that they were looking at MMC seriously. And also MMC, I think, makes it easier, or kind of really promotes using BIM properly on a common platform and using a federated model. I think too much within the construction industry, people say they use BIM, but you're not really using it to its full advantage. With MMC, you almost have to go down that route to get the full benefits out of it, which is only a good thing because of all the knock-on effects, such as the sharing of data. And once you share the data, whether that's design data in terms of being able to standardize products a bit more, or whether that's in terms of risk, project performance data, these things are only going to lead to minimized errors and improved lessons learned. Actually, on a major hospital that we worked on as project managers, we saw a significant increase in productivity, a 23% saving on program. This particular hospital went from 137 weeks instead of 197. And then the reduction in labour is important, especially with what's happening in the market at the moment with the skill shortage, which I think is likely to get worse. Being able to sort of reduce the wastage and the amount of work that needs to be done on site is only a good thing. And then, as a lot of other people have mentioned, this only helps with our sustainability targets. COP26 around the corner, the fact that we can show we've got this technology that reduces wastage, reduces deliveries, promotes doing things right the first time, and reduces that embodied and operational carbon reduction, is really an important factor in the uptake of MMC. And my last slide before we go to a quick video was again looking at how we can aid productivity and enhance collaboration across the supply chain. So BIM is central to this, as I've just mentioned. It really does promote the proper use of BIM as it was intended. And I think it's important to remember a lot of clients and consultants are still stuck in the, is modular just, is MMC just modular? And, making people aware that there's different types of MMC, panelized and component systems. And also MMC can insist on our path towards true smart buildings, because it enables you to build in the requirements, the sensor requirements and stuff early on. And started to change our language a little bit around PMV, pre-manufactured value, because it's that pre-manufactured value that leads to the greater efficiencies, which leads to the less wastage, which then obviously gives us that better carbon footprint. And then the last point I just wanted to mention was around project data analytics again, and I think Jamie talked about this in terms of automation and generative design. I think we're at the thin end of a wedge here where we're going to see that become more and more important. And the fact that the MMC lends itself to being able to provide that data means that we're going to be able to start getting better and better, start training machine learning algorithms, start training automation, robotics. All those things are just going to enhance what we do. So that's my last slide. I'm going to show a video now, hopefully, if I go back to you, Jordan. If you want to, this is only a snippet of the video. If you want to see our full video, it is available on our website at gleeds.com. If you go to the news and insights section. So hopefully a video will play any minute now.
As construction evolves, modern methods of construction and off-site manufacture is becoming the de facto choice for clients that need quality control with cost savings in a defined setting. So in this short film, we're going to take a look at a number of successful projects from around the world where modern methods of construction have saved valuable program time as well as its other benefits. The first is the Grange University Hospital in Newport Gwent, a major 55,000 square metre new build hospital with a £226 million construction value, of which 72 million was mechanical and electrical. Gleeds, as project managers, led a collaborative team and using off-site manufacture were able to hand over the hospital to their client 4 months early, under budget, and all in the middle of a pandemic. First, let's hear from Victoria Head, the project director at Gleeds, who helped drive a target of 23% savings on programme. What was the brief, and how did she and the team respond?
The Grange University Hospital was always going to be something different for us. Gleeds committed to wanting to put an innovative approach around this project. It was a very important project to Gleeds. We've been working on it for many, many years and wanted to bring into it the modern methods of construction that the industry were just starting to take up. Our client's brief was around efficiency, innovation and speed, and we responded through using modern methods of construction. We were committed to giving the Iron Bevan University Health Board a hospital of a great product as quickly as possible.
So when obviously the Grange construction and the design and putting that together came about, we were obviously keen to get this building up and ready as soon as possible.
What was exciting about this particular opportunity was the whole team was up for doing something differently and where we could push the boundaries of modern methods of construction. So we really looked at what we could explore and bring to the table in regards to what we could build off-site rather than build on-site.
There aren't many public sector projects that will say that they will be opening 6 months early in the midst of a pandemic. So we believe that this is a success story that we want to roll out to other clients, be that public or private sector. There is learning here that is ready to be used for other projects.
In the USA, the new build prison program is delivered through offsite manufacture. Chris Williams in Atlanta told me about the numerous 1,000 to 3,000 bed state prisons he has been involved in and why the client insisted on offsite manufacture.
In the United States, it's pretty much the norm to use modular construction for jails, particularly in the housing blocks. Gleeds have been involved in many projects over the years using both concrete and steel cell modular construction. So the reason that our clients want to use modular construction for jails is a combination of reasons, one of which is speed of construction. The other, and most importantly, is the quality of construction. Each pod or jail cell is essentially the same, so there's a lot of repetition. And particularly with precast, you can just really stack them on top of each other. And when you use precast double T's, essentially all of the structure then becomes modular and goes together very, very quickly. The toilet is fitted out, the hand basin is fitted out, and the bunk is fitted out. Definitely one of the benefits of modular construction is knowing that these are being built off-site safely and securely.
Brilliant, thank you so much. If I could just ask all our panelists to turn their cameras back on and unmute themselves, that would be wonderful. Brilliant, thank you so much. That was such a wonderful set of presentations. We've got plenty of questions rolling in, but before I get to all our audience questions, in my prerogative as chair, I'm going to ask one of my own quickly before we get to all the ones that are coming in. Essentially, here we're talking about how we can boost the use of MMC and offsite through collaboration. I think you've all come at that from wonderful angles. I guess my big question is what are some of the key challenges that are stopping that already happening? And I was just sort of wondering if I could get the perspectives of the people on our panel and how we could overcome those challenges. Does anyone want to jump in first? Considering I'm asking you all, I don't want to throw anyone under the bus.
Yeah, I'll dive in. A lot of it is actually, it's a bit like BIM. So BIM was never really a technological change. It was a mindset change. I mean, the technology had been around for a long time. And I think, from the examples you've seen here, no one doubts technically we can do these things. No one doubts, all of this stuff is being done. I think it's the mindset needs to shift. Things like the attitude to risk needs to change. A lot of the current contracts aren't really set up to do this. So where we've seen it fail is where people take a kind of very risk averse, very kind of that kind of I'll only look after my bit. I don't want the risk for anyone else's bit. So I think we need to open up some of those conversations, and yeah, it's going to be the sort of collaboration and the sharing of IP ideas and things that's going to change this. It's not going to be a technology shift. It's all about the culture now, I think.
Brilliant.
I'll second that as well. And what I'd like to add to that as well is currently it's not being fully adopted by the tier 1 contractors. I almost feel like it's a bit of a resistance from those guys. They're still treating offsite MMC manufacturers as subcontractors. I think they need to fully embrace it and start, looking at how they become MMC contractors fully themselves. Yeah,
I'd agree with that from our perspective. I think at the moment MMC is still seen as the alternative. It's like a lot of studies we do is done traditionally, and then what would this be if it was done in MMC, almost as a way to prove against it, whereas we've got to turn it the other way. Actually, MMC should be the starting point, and I applaud clients like the DFE who have said that MMC first, and that's the way we'll start changing things, I think.
Isla, did you have any thoughts that you wanted to add in there?
Absolutely. I mean, I agree. It's the holistic approach, I think, that is the bit that's perhaps not quite working just yet. It's making sure that we've got everybody on board, the designers, the contractor, the client, right from the get-go, to make sure that all the pieces of the jigsaw, if you will, are actually working towards getting the product to the point that I think we all know that it can be, but it's just getting everybody on board at that early stage. So for me, it really is that holistic approach, and I think we're getting there. But I think again, it's that understanding of where are we getting our products? We're under pressure from a cost perspective always, and we also have difficulties in sourcing materials at the moment. I'm sure everybody's in the same position. So it's just dealing with all of those challenges as well as trying to move the industry on. I think is one of the biggest challenges for me.
Brilliant. I better get into some of these audience questions, even though I've got plenty more of my own that I would love to put to you all. But we've got one that's coming from Michael specifically, so I'll put it to you first. But if anybody else wants to jump in off the back and come in with anything, that'd be great. So essentially, we've had some questions around how, like, ease of switching production line and how many units are required to make it cost effective to change the production line from your sort of perspective. Essentially how much scale is required to make it worthwhile, I guess.
I think, being completely open, when you do a one-off bespoke building, you don't get the true benefits of the standardization. So what we're finding, once we're producing sort of 2-3 schools, for instance, James touched on the DFE, and we're working on the MMC offsite framework. So we've got a standardized product there now, which we're rolling out across 5 schools. So it's becoming really efficient. So one-off projects, it doesn't work as well. However, with standardized details, we are improving that. But where you've got a program of works like we have with the DFE, you get huge benefits. So once you're into sort of 2, 3, 4, 5 schools, you really start to see that. We're doing a lot of work with the NetCap program with the MOD as well, and there's high repetition. So we're using the same standard details again and again. So that makes it. So once you're into a program of works, you really do get the benefits of it, and we're seeing that on the schools and the MOD projects we're working on.
Brilliant. Does anyone else want to jump in on that, or?
Yeah, so it's one of the reasons actually that government's driving platforms, because what it's saying is if you were making lots of the same components, actually every project could be completely bespoke, but at a component level, it's like Lego, like at component level, they're all the same. Or IKEA, it doesn't matter if you're making a bed or a wardrobe or a chest of drawers, the knockdown fittings are always the same, the book's always the same. So for instance, the components that we're using for Landsec for a commercial building are exactly the ones we would use for a school or a hospital. So it doesn't, the Landsec building's a total one-off, but we're already getting those benefits, and then we'll take those components somewhere else. We'll take all the processes, we'll take the robotic welding and things. So that's one of the reasons government's interested in this, is that if everyone was making the same components at scale, then a little tiny one-off schools extension would be using the same sorts of benefits that the new hospitals program will get. And they're going, so actually I can get have my cake and eat it. I can cross-fertilize all those benefits absolutely everywhere. And I think that's again the big sort of mindset shift, is not thinking in terms of projects but thinking in terms of componentization.
So I think you've probably started answering the next question I have here from our audience. Is there a minimum project size to make MMC viable? And my guess from that answer is no, if you can use, from Jamie's perspective, no, if you can use components. I'm guessing is part of the answer, but I'll let you speak for yourself. And if anybody else wants to come in, that'd be wonderful.
I mean, we've been doing this for 25, 26 years now, and lots of different sectors. We haven't yet found a project that couldn't benefit from some application of MMC. So we don't necessarily try and do everything as a piece of MMC, but almost inevitably on every project we've looked at, there is some inefficiency in the current kind of way of designing, procuring, manufacturing. So to a greater or lesser extent, we haven't found anything yet that couldn't be improved by some form of, one of these versions of MMC.
I think that's quite an important point, Jamie, is that it's not an all or nothing, is it? You can have elements of MMC, and every project could do with some element of MMC quite easily. To go to the full volumetric design, obviously that needs some kind of quantity around it to make it work. But when you start bringing it down to the component level, I think pretty much every project, in truth, probably a lot of projects have got it already in it, and people don't even realise.
I think again from one of the slides that I was showing, that you can have the reuse of the building and the retrofit of existing buildings, which is important in terms of carbon calculation and not knocking down buildings, and have the benefits of modular with your weight saving, and particularly in tight sites or in remote areas, that's all really important. So it's not a case of it has to be a hospital or a prison. It can be quite small projects, as long as it's thought about early enough.
Yeah, I agree with that. Yeah, I don't think there's any minimum size to make it worthwhile. We've done, obviously, we are a volumetric MMC contractor, and we've done schemes that are 1 or 2 modular bays in size. But again, you're using the volumetric system, using the standard details, so you are still getting the benefits, no matter if it's a really small project. We've done standalone, as an example, over the COVID pandemic for the NHS. We did some MRI scanning units and CT scanners, which were in a single unit, and we were able to fully finish those in our factory, test all the M&E, so they were fully operational. As soon as they went to site, they were almost like plug and play. So there was an example of, there was a building that essentially was only 1 module in size, 1 volumetric module. So yeah, it can be from any size, from 1 unit to 200 units.
Brilliant. Okay, I know we've only got a couple of minutes, but we've got a few questions on the same thing, so I'm just going to try and squeeze one more answer out of you all. So essentially, we've had a couple of people asking about program benefits and the overall program benefits when you take into account the design and manufacturing periods too. So how do you make sure all those benefits are actually realized, and that you're not sort of losing it between different stages? Sorry, I've tried to roll a few questions together there, and I might have just made it a bit jumbled.
So we're generally finding that we can do the whole thing quicker now. So with the automated design, the algorithmic computational design, we're able to certainly compress the design phase. You can see from the kind of speed with which we can transfer things to we've done a number of projects now where we've robotically laser cut the components and things. So we're seeing compressions in program of all of those things. We're also finding on the Forge, for instance, that because of the way the superstructure works, we're releasing floor plates quicker below. So we're telescoping the program and getting rid of some of the critical path things. So yeah, we're on individual projects getting all of these benefits. I think once we get into this kind of platform mindset, we're going to see a dramatic shift in how long we think it takes to design and build a building, and we'll do things that we currently think are unthinkable will become kind of business as usual within 5-10 years, I suspect.
Brilliant. Anybody?
Yeah, from our perspective, in the pre-contract stage, using sort of offsite MMC, it forces you to fully design everything up front. So you work. By the time you get to the end of stage 4, you're literally going to start manufacturing straight after. Whereas a traditional model, you sort of design as you go along as the project progresses. Certainly with ours, it places a lot of emphasis on the front end design and getting that nailed down straight away. So I find there's a lot more front end engagement from all parties to come together and work collaboratively to do that. And also, I know from personal experience, we're on a number of projects where the day we start on the ground with the foundations, we're also starting on manufacturing. So you've got that program overlap, and that's where we're getting the huge benefit of program savings on live schemes. So by the time we finish the foundations, we're dropping in a building that's 80% complete because we're getting such high PMV value. You know, and you're saving up to 50% of your site time.
Completely.
I think in terms of forcing people to understand what they want at an earlier stage is only a good thing. The industry historically has, you know, left too many things to the point that you're on site. But if you don't do that, then you could still have problems, because actually introducing change to the MMC process can be quite costly. So it is important that you do get that early engagement from the right people as well, because you may do things in, you know, in the right spirit, and then somebody else comes along by the time you start manufacturing and say, actually, I want to change things. That can be a bit of a fly in the ointment. So it's important you actually, it's a cultural thing. You identify the right people early on to set the brief properly, so that you're not likely to make any changes.
Isla, did you have any last thoughts there for us?
Yeah, I mean, from my point of view, it's quite interesting. I think one of the other panelists had put up where we had the REBA stages, and traditionally how you would follow, you know, this would happen, planning, and then you would, quite often engineers are brought on quite late, and could be after planning, and at that point sizes of windows, etc., have been agreed. Getting stability systems into either from a temporary lifting point of view for modules, or even just from a permanent stability point of view, can be a challenge. So I think program wise, you could really make some savings even in the design if you bring on the right people, and you can let go of that traditional, you know, it's only the architect up front and the engineer comes on after, and then the services engineer, and then. I think that in itself, if we can get a little bit more collaborative earlier on in the process, it can only help in terms of getting those modular buildings really efficient and really make the savings, which I think are possible. So it's just a slight change in our sort of DNA as an industry as to how we go about things, and that's having clients who are quite well educated in the subject, and they're quite happy to be innovative and take that approach where they're, you know, if you get your designers on it quickly enough, then you really can make those savings. So yeah.
Brilliant. Oh, I can't believe we're already out of time, but I wanted to thank all our panelists. I think we could not have asked for a better session to kick off Digital Building Week. So thank you all so much for your time. We really appreciate it. Just to flag to our audience, we have another session this afternoon on collaboration and how that can be useful in the pursuit of sustainability goals, plus a whole week's worth of content which can be found on any of our homepages, so building design, or housing today. So again, thank you to our audience. Thank you especially to our panelists. That's it for this session. Thank you and goodbye.
Thanks all.
Thank you.